Good afternoon all. This is Satish Kumar, Assistant Professor of EC Department. Now let us discuss about the case study on flood prediction system using real-time sensor signals using digital signal processing. See, first introduction. Floods occur. Floods are frequent and devastating natural disasters. Traditional monitoring, manual observations and weather forecasts are used. DSP advancement, digital signal processing technology emerge in terms of flood prediction system. Continuous monitoring, environmental conditions are continuously monitored and accurate predictions, flood occurrences are predicted more accurately. Next, flood prediction system process. First is sensor data collection, data processing, trend analysis, early warning generation, preventive measures and damage reduction. Sensors gather data on rainfall, water levels and soil moisture. DSP algorithm process and analyze the collected data. Then algorithm identify the patterns and trends in the data. The system generates early warnings based on the analysis. Authorities and communities take preventive actions. Preventive measures helps reduce flood damage. Next, flood prediction system challenges is of rapid urbanization, deforestation, climate change, delayed data, limited prediction. Rapid urbanization increased water runoff, drainage strain. Deforestation reduced water absorption, increased erosion. Climate change more extreme weather events. Delayed data slows sensor readings, late warnings. Limited prediction, inaccurate forecast, insufficient lead time. Need for flood prediction system. First, we can implement the real-time flood prediction, issue evacuation orders, mobilize rescue teams, utilize DSP for data processing. First, continuously monitor environmental parameters to detect potential flood conditions early, allows authorities to evacuate vulnerable communities before a flood occurs, enables rapid deployment of rescue personnel to assist affected areas, ensure quick and accurate processing of sensor data, reducing false alarms. Next, flood prediction system objective is of real-time monitoring, digital signal processing, automation and decision support. Serial continuously collecting data from sensors to track environmental conditions, using digital signal processing and advanced techniques to clean and analyze sensor data, automating flood detection and warning process for faster response, providing crucial information to agencies and communities for emergency management. Next, role of digital signal processing. First, analog signal collected, noise removal, flood event identification, analog to digital, trend revaluation, and then future flood estimation. Analog environmental sensors capture physical parameters as analog signals. DSP filters removes the unwanted noise and disturbances from the data. Algorithms identify patterns associated with previous flood events. Analog signals are converted into digital signals for computer processing. DSP smoothing techniques highlight long-term trends in the data. And then DSP predicts future water levels and flood probabilities. Next, flood prediction system sequence is of sensor networks collects data, communication system transmits data, DSP processing data and analyze the data, prediction module estimates flood conditions, alert system distributes warnings. Sensors gather environmental data from flood prone areas. Data is sent to the central processing unit via wireless technologies. Advanced algorithm process the incoming sensor signals. Future flood conditions are estimated based on data. Warnings are sent through various channels when flood risks are detected. Next, sensor technology is used is of comprehensive understanding, combines sensor data for accurate predictions. Flow rate sensors measures water speed and volume. Soil measure sensors determine soil water content. Rainfall sensors record precipitation intensity and duration. Water level sensors monitor water height in bodies of water. And then working principle, sensor monitoring, signal transfer, pattern identification, alert activation, and then analog to digital, noise reduction, future estimation, notification. Environmental sensors continuously measure water level, rainfall and moisture. Digital levels are transmitted to the processing unit. Processed signals are analyzed to identify the blood related trends. If flood probability exceeds threshold, warnings messages are generated. And then analog sensor signals are converted into digital format. DSP algorithms filter data to remove noise and improve the quality. Predictive models estimate future flood conditions based on data. Warning messages are sent to authorities and residents. Then DSP algorithms and techniques are used, low pass filter, and then fast Fourier transform, correlation analysis, time series forecasting, and adaptive filtering. Low pass filter removes the high frequency noise from sensor readings. Moving average filters smooth data fluctuations and reveal long-term trends. Fast Fourier transform identify periodic patterns in environmental signals. Correlation analysis determines relationship between rainfall intensity, water levels, and flow rates. Time series forecasting analyzes historical data to predict future water levels. Adaptive filtering dynamically adjusts system parameters based on changing environmental conditions. Next, benefits and applications is of early warning, real-time monitoring, improved accuracy, diverse applications, and emergency support. Communicates can evacuate before flood waters reach dangerous levels. Real-time monitoring, continuous awareness of environmental conditions enables informed decisions. Improved accuracy, automated data analysis reduce dependence on manual observations. Diverse applications, technology include river basin management and coastal flood management. Emergency support provides timely information about flood severity and affected areas. Now, challenges and limitations. Sensor small fluctuations, sensor failures can disturb data collection and reduce the accuracy. Extreme weather can damage equipment and interfere with communication. Technical expert skill personnel are needed for network maintenance and upgrades. Environmental challenges, unexpected environmental shifts can impact forecasting performance. Communication failures, network issues can hinder data transmission and prediction reliability. Financial investment, maintaining large sensor networks requires sustainable financial resources. Data quality, the accuracy of predictions depends on the availability and the quality of historical data. Now let us conclude. We can collect the environmental data. Sensors gather real-time environmental data. Generate flood forecast. Accurate and timely flood forecasts are produced. Implement warning systems. Automated warning systems are put in place. Enhance system capabilities. Advancement in DSP, AI and IoT improve system capabilities. And then analyze the sensor signals. DSP signals process large sensor signals. Integrated sensor signals. Sensor networks are integrated with communication technologies. Ensure rapid response. Rapid response to potential flood the test is ensured. And then advancement in DSP, AI and IoT can improve the system capabilities. Thank you.